Okay, so today we do section 9.1 vector space. All right. Okay, so I will write down definition vector space first. Definition vector space. A vector space V is a set of vectors with two operations. What kind of operation? Addition. Okay. And scalar multiplication. Scalar multiplication. Which satisfy the axioms of additions and scalar multiplication. Okay, so we have 10 axioms there. Let me write down. So I'm going to combine the addition and scalar multiplication. So axioms of addition and scalar multiplication. Okay, number one. So let V, W, Z be vectors in a vector space V. Then they they satisfy following the axiom. So number one, close on the addition. So if you, V, W in V and V plus W is also in V, right? So we call closed on the addition. Okay, so second one, V plus W equal to W plus V, right? So commutative. And number three, and associative law. So V plus W plus Z is the same as V plus W plus Z. We take the parentheses there. And existence of additive identity. So V plus 0 gives the vector V. Number 5, additive inverse. So we call this is the additive inverse, right? 0 vector. Okay, now scalar multiplication. So we have a scalar, which is, let me denote A and B, is in real number. So number 6, maybe I can do this on the side. Number 6. Sorry, hold on 1 second. Okay, number 6. So scalar AB, so A, which is V plus W equal to AV plus AW, right? And we have a 7. We have A plus B scalar and V, which is AV plus BV, right? And number 8, we have A, B, V. I should I use a B? BV. So ABV equal to, we have a associative in multiplication, which is ABV. Okay, number 9. I'm missing that. Number 9. We have a AV is also in V. So let me write down the scalar multiple of V by A. Okay, number 10, we have a 1V, which is V. That's a multiplication identity, right? So that is the 10 axioms. Okay, now.
Is number 10, is that 1?
1, yeah, that is 1. It's a 1. 1 times the V, yeah, which is V. That's a multiplication identity, right? All right. Okay. Now, we want to know about this. I don't want to show that, the vector space, because it's too many axioms, right? So I'm going to just say that R3 is in vector space. So let me denote this one. So just I'm going to say note, right? Note. Rn under the usual, they say the operation of vector addition and scalar multiplication is a vector space. Okay, let us do example that. So we have also this one, polynomial, and then sub 2. This means it's the set of all polynomials and most 2 and most degree 2, as well as the 0 polynomial. And is a vector space. Okay, so what is the polynomial sub 2? So this is, looks like that. So a sub 2, x sub square, x to the second power, a sub 1, x plus a naught, such that a sub y is in real number for all I. Okay. Now, so this is also vector space. So we have M, they denote like that. 2 and 3 is the set of all 2 by 3 matrices. Matrices is vector spaces. Okay.
I have a question. A couple lines up, right to the left of that vertical bar. What is that little subscript? Is that a 0 next to the A?
You mean this one?
To the left.
To
Is
the
it-
left, A naught.
Oh, A0. Okay, 0.
A sub 0, yeah, A naught. We call A naught.
Okay, thank you.
You're welcome. Okay, read A naught. This is a spell right? Not. Is it spell right?
I think it's N-A-U-G-H-T.
Not, yeah, not.
N-A-U-G.
Yeah, and thank you.
English is a hard language to spell.
All right.
Yeah, I just call it A0, A sub 0. Yeah.
A sub 0, yeah. Not, yeah, not. Correct. Thank you very much, everyone. All right. Okay, so let us do this one. Example. All right. Okay, so we have a vector space and xy, and x is greater than 0, y is greater than 0, is a vector space. Okay, let's pick the number so that we can show that u equal to 2 and 3. Yeah, so this is consider x and y, right? Means that x is positive, x is positive and equal to 0 or equal to 0, 0 is okay, or y is positive or equal to 0, right? Okay, so we can have a u equal to 2 positive number as xy, and v is 1 and 2. Yeah. Okay. So let's say, let's show that UV on the closed addition, right? So number 1, U plus V also in vector space, right? So which is 2, 3, and plus V 1, 2. Okay, so what do you get? 3, 5 is also in V. Yes, because x is positive, y is positive, right? So it's also in V. Yeah. How about second one?
Wait, what do you mean? What are you saying here?
So I am showing vector space by axioms. Yeah. So individual vector is in vector space, and then is it closed on the addition? Even though we added them, still in vector space.
Okay.
Make sense?
Yeah.
Okay. So this is still x and y is positive. So yes, it's in still in V. So it's under closed addition. Okay, second one, commutative. So U plus V is the same as V plus U. Yes, right? So 2, 3 plus 1, 2. Equal to what you get? We have a 3, 5, which is the same as 1, 2 plus 2, 3, right? Okay, third one, associative. All right, so we have to pick W, right? So that's W, pick any number for any positive.
7.
7, 4, how about that, right? Okay, so we have associative U plus V, oops, plus W equal to U plus V plus W, right? Okay, so we have 2, 3 plus 1, 2 plus 7, 4. Okay, so there will be, we have 3, 5 plus 7, 4. So what do you get? 10, 9. So is it same as we have 7, 4? I'm crazy right now. So 7, 4. 7,
I do that too sometimes.
really?
Yeah, like I'm making a fraction or something.
Oh, this is the first time I do that. 7,
Wow.
4.
Congrats.
Plus, yeah, 7, 4. Okay, hold on. Don't talk to me. 7, 4. I'm crazy right now. Don't talk to me. No. So we have 2, 3 plus 1, 2. 1, 2 and plus 7, 4. Okay, associative this way, right? So this is 2, 3 plus what you get is 8, 6, right? Okay. So this is, all right. So we have 10, 9, yeah. So we get the same, right? So I don't have to do that. Okay, now we have number 4. Okay, so let's make a U and vector 0 is the same as U, right? So U was 2, 3, 0, 0, which is 2, 3, right? Which is U, right? Okay, number 5. We have a U plus negative U, which is 0. So we have a U here and plus minus U. So that is 2 minus 2, 3 minus 3, which is 0, 0, right? Which is 0 vector. Okay, now. Whew. And scalar multiple. Oh, let me try 6. Scalar multiple, that must be 6. The scalar multiple of U by A. So AU is still in V, right? Okay, so scalar multiple, let me pick A. A is any real number, right? So negative 4, yeah, as A. Okay, negative 4 times U So we get -8, -12. It's in V. So V is this one. V is X and Y. And X is the positive or equal to 0. Y is the positive or equal to 0. So do you think this is correct? This is close. Is it still in V? No, right? Because this is negative, this is negative, right? So this is not, right? So this is a violated vector space, yeah? So must be positive in that case. Not in. Let me denote like that. It's not in V, okay? Since X must be greater than 0, Y must be greater than 0. Yeah. Make sense? So we don't have to check the rest.